Lesson 23. Make line plots and interpret data. In this lesson, we will talk about how to read a line plot, make a line plot, and solve problems using data from line plots. Here's our first line plot, and we'll read it so that we're just going to make sure that we understand what a line plot is trying to tell us. Mason sold pumpkin seeds at the farmer's market on Saturday. The line plot shows the different weights of the bags he sold. What is the total weight of pumpkin seeds sold on Saturday? So every single one of these X's is a different bag, and that's important for you to know. He wants to know what is the total weight of all the pumpkin seeds sold on Saturday. So one X is a bag, and each of these down here is the weight of each X on top of it. So there are 2 bags at 7/8, so right here. There's 1 bag at 5/8. There is 2 bags at 1/2, so there's 2 halves here. There are 4 bags of 3/8, so there should be 4 3/8 added. There are 3 bags on the 1/4 and 2 bags at 1/8. And so we have to add those all up to figure out what the total is for the weight of pumpkin seeds sold on Saturday. Now, if you notice, some of these denominators are different. So the best way to do this is, of course, to find your least common denominator, which would be, in this case, would be 8ths. So that's why the answer is in 8ths, because you cannot add 4ths plus 8ths plus halves without switching them around to make sure that they're all in 8ths. So the total weight of everything that he sold was 5 7/8. A line plot needs to have the following: the X's, which represent each item, some kind of scale at the bottom, so it might be amount of money spent, or it could be weight in pounds, or the height of something. There needs to be something here at the bottom, and of course we need to have a label for that. So at the bottom here it says pumpkin seed weight. Pumpkin seed weight in pounds. That's really important that whoever is reading your graph knows what you're talking about. So we need the plot, so the points on the graph. We need something that's being measured, and we need that to be labeled on our graph. So we're going to use all of that to make our line plot. Gabe has a collection of stamps. He recorded the heights of the stamps along with the number of stamps at each height. So if you remember, we're going to put an X for every stamp. We also have, so we're going to have, we're measuring the height in inches of the stamps. So we're going to put that on this line down here, height in inches. So I say that in inches. And what's really important is when you're doing a number line, always start with 0 unless they tell you to do something else. So we have heights that are as small as 1/2 and as big as 3. So we're going to need to put all those heights in order from least to greatest. So we have 0, 1/2. What comes after half? 1, 1.5, 2, 2.5, and finally 3. How many stamps do we have at 0? None. How many stamps do we have at 1/2? We have 2. So we put 2 X's there. How many stamps do we have at 1? We have 5 that are as high as 1 inch. 1, 2, 3, 4, 5. How many are at 1.5? 9. So we're going to put 9 X's. 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many stamps are 2 inches tall? 6. 1, 2, 3, 4, 5, and 6. And try to keep your X's to be the same size. I know it's really hard. How many stamps are at 2.5? 3. 1, 2, 3. And how many stamps are at 3 inches? Only 1. So let's go through the checklist. Do we have our data points? We do. Do we have a label? We do. And do our numbers go in order from least to greatest? They do. And that is an awesome line plot. So the next thing we're going to look at is how to interpret that data. So understand it better. Kelly works at a grocery store. One day, she recorded the weight of each melon before she put it in the bin. The line plot shows the data. We'll be looking at melons and their weights. Wow. So on her line plot, Kelly clearly has a lot of melons that weigh 1.5 pounds. She only had one melon at 3 pounds. That must be a very large one. And she had 2 that were pretty small at 0.5 pound. So as soon as you see a line plot, you can start making different inferences about what's going on in the story as a whole. Maybe most melons are 1.5 pounds. Okay. Maybe it's really rare that a melon is 3 pounds. Let's take a look at some of these questions. Look at the data in the line plot. Which statement about the data is true? We're going to go through each of these options and either cross them out if they don't make any sense or investigate a little bit deeper to see if it's true. There are 3 melons at the heaviest weight. Well, let's take a look. What was the heaviest weight? We have 0, which is the lightest, and 3, which was the heaviest. Were there 3 melons there? Nope, there's only 1. So that is not true. B says the heaviest melon is 2.5 times the weight of the light. 1.5 times 2.5. Will we get 3? Let's check. In order to multiply properly, I'm going to change this into an improper fraction. So I'm going to have 1/2 multiplied by, let's see, multiplied by 5 halves, which was, let's go over here, 5/4, 1 and 1/4. That is not 3 pounds. Let's cross that out. All of the melons weigh between 1 and 3 pounds. Let's check. Do all of the X's fall between 1 and 3 pounds? Nope. We have 2 that are smaller than that. So that is false. The weight of the greatest number of melons is 1.5. Is that the weight that has the most melons? 1.5 has the highest stack there, has the most X's. There are a lot of melons that have the same weight. That is true. Shrina chose B as the correct answer. How did she get that answer? Why would Shrina think that the heaviest melon is 2.5 times the weight of the lightest melon. I wonder if she understood her math action word of times. She might have subtracted, because if you have 3 minus 2.5, you would think the answer was 1/2. Next time, Shrina should check what her math action word is before she gets started. So just in that one example, we were able to figure out lots of things just from looking at the data. We were able to figure out the heaviest melons was, the most common weight of melons, the lightest melons. We were able to do a lot, and we were able to figure out what was true and what was not true. This has been Lesson 23. Make line plots and interpret data. We read a line plot, we made a line plot, and we solved problems using data from a line plot. Thanks for watching.